So here we are graphing. We finally get to graph. We're graphing our rational functions or rational equations. Let's talk about the parent graph first. Y equals 1 over x. I'm just going to do a quick table, right? Just a quick one. Let's see. Let's just do like -2, -1, 0, 1, and 2. If we plug those in, if we plug in -2, we get -1/2, here -1. But what happens when you plug in a 0? What's 1 over 0? Can't do it, right? Empty set, and then of course 1 and 1/2. So that's what I want to talk about first, is this empty set, right? What happens is we get a vertical line that the graph is going to approach but never cross. And that's what an asymptote is. An imaginary line the graph approaches but never touches. And we can have two kinds of asymptotes, vertical and horizontal. So let me get this down. It approaches it but never touches it. So if it's a vertical asymptote, it's obviously straight up and down, and it's an x equals line, have x. And if it's a horizontal asymptote, it's a horizontal line, and it's obviously a y equals. The rational functions have a vertical asymptote and a horizontal asymptote. So the parent graph has a vertical asymptote at 0, and what that means for the domain is that x is not allowed to be 0. If I graph my ordered pairs like -2, -1/2, -1, -1, and then 1, 1, and then 2, 1/2, that's just going to give me a little clue. I might use my graphing calculator here even to show me this graph. The red is the graph. So what does that tell me about the horizontal asymptote? Right, the horizontal asymptote is at 0. Why is y not allowed to be 0? Well, look at your original equation, right? What do you have in the numerator? A 1. Can a fraction ever be 0 if the numerator is 1? It cannot, right? So it's not ever going to equal 0 for y. So once we know our parent graph, then it's not bad to do our shifting patterns, right? So what do we know about adding 2 on the outside? It's going to take our graph and move it up 2. So what I like to do is just take my asymptotes, or what I call the dotted plus sign, and move it up 2. So if you look at that, x is still not allowed to be 0, so the vertical asymptote is at 0. Y is now not allowed to be 2, right? Y is not allowed to be 2, so the horizontal asymptote is 2. Then if you fill in the graph, sometimes I just fill in like basically these two dots. It's kind of the -1, 1, 1, and then -1, -1 shifted up 2. And you could just do your swoops here. Just make sure you have arrows on the end and that you're approaching the asymptotes but never crossing them. And you can use your graphing calculator to confirm it, right? What's going to happen in number 3? X minus 3 in the denominator moves it right 3. So my dotted plus sign that used to be right in the middle is going to move right 3. So my x is now not allowed to be 3, meaning a vertical asymptote at 3, and y is not allowed to be 0, so a vertical asymptote at 0. And then you can fill in your swoops. We've got a combo shift here in number 4 where it's going to go, what? Left 3, down 1. Left 3, down 1. So I take my dotted plus sign, I move it 1, 2, left 3, and then down 1. So this means that the x is not allowed to be -3, vertical asymptote at -3. The y is not allowed to be -1, vertical asymptote at -1. And then I fill in my swoops. That's it. Now it's getting a little more complicated in the next row. Well, the first one, number 5, is multiplying by a negative. What did we say that multiplying by a negative does? Right, it reflects the graph over the x-axis. So it's going to reflect over x-axis. Is that going to affect my asymptotes? It is not. It's still going to have a vertical asymptote at 0 still going to have a horizontal asymptote at 0. If I take my parent graph and reflect it over the x-axis, it's just going to look like this. Ta-da! Now, all you need to know for the test is 1 through 5. 6, 7, and 8 are ones that we're going to do on the graphing calculator, really. I can tell the domain and range, though, but just by looking at the equation. What we want to get you ready for is knowing, like, I can look in the denominator and say, what is x not allowed to be? In other words, what x value is going to give me a denominator of 0? Right, -3, right? What y is not allowed to be is a little trickier. Does anyone know what y would not be allowed to be? You're right, y is not allowed to be 1. Why? Why is y never going to be 1? Right, because the numerator and the denominator here are never going to be the same. Right? They're never going to be the same. 1 is always going to be 1 less than x, and 1 is always going to be 3 more than x, and they're never going to be the same. Now these graphs, I'm never sure exactly how they look, right? Because it's not really a shift to the parent graph. So I've got to do these on the calculator. So if I graph this on the calculator, I can see where it fits in here. So this one here looks like this. But you do not need to graph the harder ones like that on the test. Just filling in the asymptotes here, I'm not even going to do the graphs, but just filling in the asymptotes. What is x not allowed to be in number 7? Right, x is not allowed to be 3 because it would make the denominator 0. Do you know what y would not be allowed to be? Right, y would not be allowed to be 2 because the numerator is always a little more than double the denominator. It's never going to be exactly double the denominator. And then number 8, the domain, in number 8 would not be allowed to be either 1 or -1. So we've got a vertical asymptote at 1 and -1. And then the y on that one is actually not allowed to be 0. Those are more advanced. Those last ones are going to be more of a pre-calc kind of question. So they're not on the test, but I do just have some exposure to them on the homework. But as long as you know how to do 1 through 5 with a calculator, you will be good on the test.